Hi, everyone. It's really excited to be here. And I'm Dr. Mingjng Lin. I'm a senior lecturer at the University for the Creative Arts. I'm also teaching at Kingston University, teaching about fashion technologies. And my previous PhD research was conducted at the Royal College of Art in London, and it was about 3D printed parametric design and parametric thinking for body-oriented parametric design, parametric thinking 2.0 for 3D printed textiles and fashion. And the idea of today's presentation is to first demonstrate my previous PhD and practice research, and also I'll provide a brief overview, timeline analysis of 3D printed fashion and textiles with a full respect to many other wonderful works and amazing people who are going to be presenting here today. Okay? So the presentation is going to have 5 sections. First, I will introduce my speculative initial research project when I began my PhD research in 2014. And the second, I will provide an overview about pioneering 3D printing fashion textile practitioners' work. And the analysis in this section, like I said, will help me to find the niche area and research gap. So I was able to really map out my research within that timeline. And this timeline also includes presenters, exhibitors, artists' work, which you're going to see today. And then I will demonstrate 2 of my major PhD research, interfashionality and folding interfashionality. I will finally conclude the presentation by talking about the opportunities ahead of us and also the current practices and research I'm involved with. Okay? And if you have any questions during my presentation, just raise your hand, you can ask me. And so when I began my research in 2014, I was thinking about using 3D printing as a technology technique or tools to really investigate the relationship between the wearing material and the garment and also the viewer. So in this project, bond responsive material, I use face recognition technology and place pinhole camera within the woven structure of the fabric and to capture viewers' facial expression data and then transfer facial expression data into motivating the auxertic structure to create interactive textiles. For those of you who don't know what is auxertic structure, it is a structure when you stretch it becomes thicker, perpendicular to the applied force, meaning that interesting 3-dimensional geometry and pattern were activated and created by the electronic servers. And this was presented as an art installation, interactive installation. Is the microphone working? I don't think so, right?
Can everybody hear?
Should I volume up my voice?
Yeah.
Okay. Okay, so in the following project, I collaborated with material bioscientists from Imperial College, and we sort of speculate, imagine what's going to happen in the future if we use 3D printing to really hack our garment as the second skin. So this is a really speculative project. We imagine a group of future cyber who can really turn their second garment into the second skin so that they can get nutrition and energy from the body and skin circulation system. And eventually we produce this speculative fume project. And then in these following projects, I was trying to discovering, by using the available 3D printing material, how we can maximum consumers' experience by getting them involved with the design and making process. So specifically, I invite consumers to draw, hand drawing, whatever pattern they like. And my job, our team's job, is to transfer their rough drawing into three-dimensional geometrical pattern. And eventually, I produce the 3D printed fabric toolkits on the left-hand side panel. And how they can get involved with the process, they can choose whatever pattern they like on the left-hand side panel and place them onto the garment to replace certain parts of the garment. Okay. And beyond that, another project in which I collaborated with material scientists from Royal Institute of Technology in Sweden, and we create the 3D printed phase change nanocellulose hydrogel. So it is a type of smart textile, can either absorb or release heat according to the changes of the environment, and thus offer thermal comfortability. Based on the laboratory experimentation, I created novel applications. Okay, so as you might notice, as a practitioner designer, I took this multidisciplinary STEAM approach. STEAM stands for science, technology, engineering, art, and mathematics. So it's very much about using multidisciplinary tools or skills for fashion and textile application. And then the research began to really branch out to many other fields, not only 3D printing, parametric modeling, generative design, but also coding, architectural, animation, material technology, interactive technology, etc. But the problem with that STEAM approach is that the research began to lose the focus. Okay? So in order to generate a more concrete research and concrete research questions, I thus began to analyze pioneering 3D practitioner, fashion textile practitioners' work by, for instance, organizing conference, discussing urgent issues, and interviewing practitioners, and discussing prompt new ideas with them. Pretty much like what we're going to do today. This conversation, communication really helped me to rethink about my own research. And this includes a digital fashion 3D printing for designer conference I organized at the Royal College of Art in 2016. And there are three analyses that has been drawn upon through the analysis. First of all, the first summary conclusion is that parametric design, this concept, the term, or technology has been mentioned again and again by designers. They use parametric design to create novel fashion textile geometries, 3D printable geometries. Parametric design is a design technique and skills that using algorithm, computational definition to create those never seen before complex, intricate, delicate geometries. But more importantly, they not only use those techniques, but also began to develop the use of digital tools into a new way of thinking, parametric thinking. Okay? And then the second analysis, coming from my analysis of those amazing works, you can search on the internet or through doing research via journals, articles, books. Okay? So the second analysis, the collaboration between fashion textile designer and 3D printing company or 3D printing developer is becoming more and more important. So here I use this timeline to really analyze most influential practitioners' work from 2000 until 2019 when my PhD research ended. I'd like to acknowledge, first of all, please allow me to acknowledge the contributors of today's event on the timeline: Mark Beecroft, Travis Fitch, Francis Murphy, and the Model Click project produced by Mark Bloomfield, Dr. Sean Borstrock, Our Own Skin, Cookson, Gold, and their collaboration with Bolt and Stem. And please bear, I mostly include their either most influential work or their early on work. And I'm pretty sure they will up to date you guys about their latest innovation creations later through their presentation or exhibition. Okay? And back to these analyses. For instance, Materialise produced this very interesting flexible material TPU92A1 in 2013. Even before, Materialise is one of the leading 3D printing company. So even before the company launched their products, Iris Van Herpen, Julia Corner, the 3D printing fashion textile creators, they use this material to showcase the 3D printed haute couture piece during Iris Van Herpen's fashion catwalk. And that approach really, really demonstrates the importance of collaboration. On the one hand, fashion textile designers like us were interested in collaborating with tech company, 3D printing company, to use the latest material technology to really create those avant-garde practices, right? And on the other hand, tech company, 3D printing company, they're interested in collaborating with fashion textile designers because they want to test the boundary of their technology, test the possibility of their technology beyond their, let's say, familiar realms. Okay? And sometimes they also use the beautiful fashion performance, catwalk images to really promote their products as well. Okay? And the third analysis was that the collaboration is also happening in terms of the 3D modeling and the digital design aspects. Here, this diagram demonstrates that the majority of the fashion textile designers, very often, they are quite interested in 3D printing, but very often they're supported and collaborated with either product designer or architects who are more fluent with those digital skills, because conventionally we were not trained with those digital modeling design skills, right? So we have to collaborate. And then this analysis really helped me to rethink about my own research and to rethink about the position of fashion textiles. I did collaborate with with 3D printing companies, and I used their latest material. And I also learned parametric digital design skills from, let's say, my collaborators, architects or product designer. But more importantly, I began to emphasize or embed my knowledge of the human body from a fashion textile perspective, such as knowledge of pattern cutting, garment construction, textile making, into the use of 3D printing and parametric design. Okay, so really emphasizing your own knowledge, your own perspectives of making when you do these multidisciplinary collaborations. To emphasize, legitimately, 3D printing technology was very much pushed forward by material scientists, engineers. And the parametric design, like I said, was quite often experimented by product designer architects. They were trained with these skills. Okay? They are still being trained with these skills. And for fashion textile designers, it is really our opportunity here to bring our own knowledge or area of expertise into the multidisciplinary collaborations in order to create new design outputs and even to challenge the existing business models. That's what do I mean by body-oriented, 3D printed fashion textile, the understanding, the awareness of the human body, movement, pattern cutting, body shapes, etc. And that's also helped me to rethink about parametric thinking and to generate a new term called Parametric Thinking 2.0 as part of my PhD research completed 2 years ago. Okay, so any questions so far? Okay, no? So interfashionality, fold interfashionality are two of my major research projects. The first one is the 3D printed qipao for physical performance. Qipao is a type of a Chinese dress. So in this project, again, like I said, I wanted to challenge the boundary, and therefore I challenged the boundary of 3 pairing of oppositional elements: modernity and tradition, digital technology and craft, and even Eastern and Western design elements. Meaning that in this project, I not only use parametric digital design tools to generate a variety of patterns, but also reference to Eastern pattern cutting and garment construction. Okay, that really inspired me a lot. And even though I could use digital animation rendering software to really visualize the final look of the design, I still demand the sensory tactility as a maker. Because for me, like Jonathan mentioned, without seeing and actually playing and touching that material, it's very difficult to imagine how the material will behave in real life, right? And in this case, I decided to use textile deep dye. I only have a couple of spare samples here, and I have more samples outside. I use textile deep dye to really create blurred edge of different material by adding this gradient color effect to the transparent 3D printed resin. And this adding hand making into the final 3D printed work, the merging between the hand and digital was recognized as a material innovation. And I used one of the spare samples to create myself a part of the evening dress again to attend the 3D printing industry awards. And many 3D printing companies were quite curious how this material were made, because for them, 3D printing is already an end production. This textile approach to making really enable the integration become more complex in color and detail, thus offer innovativity to the design and making output. And this concept of movement and body fluidity was presented through performance, because that's emphasizing raising awareness of the human body. It was emphasized again through this physical performance, wanted to test out the relationship between the body and the wearing materials. Okay, so that's the first major research project. Okay, and then in the following project, the 3D printed pleated costume for a Beijing opera, I challenged the more oppositional transitions by using advanced 3D printing technology supported by Sintered 3D printer, the 3D printing company, and their soft SLS 3D printing technology. You can see this material lace-like fabric. Okay. And in my thesis, I have read a lot about the oppositional transitions. And here, I'm only going to demonstrate 3 pairings of oppositional transition: serendipity and problem solving that are combined in my digital making process. Hand making and digital making are combined in my design process. I try to build an unfamiliar scenario through familiar things and trying to merge different things together to present work. Okay. First pairing, problem solving, and the serendipity approach. Problem solving approach can be found in my use of algorithm-based program, and I remember when I create. At the beginning, when I create this pleating pattern, I use kind of a scientific testing approach. I change the parameter of the algorithm and to test the different output to really get that pattern right. Okay, run more than 100 samples and 57 tests, etc., to really solve the specific problem. But then, on the other hand, serendipity approach really enabled me to create, let's say, accidental, beautiful design stuff. I create this algorithm definition to experiment with woven structure. Okay. And in a common condition, the U and V each has one corresponding and active number representing the number of warp and weft thread. I wanted to give U and V the same amount of thread number link here and here. So generally speaking, in a common condition, I would have removed the link of V firstly, but by accidentally, I added 2 active number to the input V. Let's see what happened. Then all of a sudden, an array of curved filament were created on top of the plane, or we could say the ordinary woven structure. So therefore, in my research, there's always this bouncing between problem-solving approach aimed at solving specific problem by using professional knowledge and the speculative quality of creation, which allows unforeseen results. And then the relationship between digital and handmaking. The original fold was created by my collaborator, Dr. Caijun Huang, and then I transferred into digital format for 3D printing. And in this process, digital technology firstly helped me to reduce tedious repetition and enabling rapid visualization. And then secondly, digital technology can also help me to create a pattern that couldn't be easily made by hand. Huang is a specialist in hand folding, and this on the left-hand side, it is this 3D printing folding, and you're gonna see that sample outside. And on the right-hand side is hand folding. And here grade is almost impossible to create these curved folds by hand without any digital support. Let alone we're talking about molding the folded surface into much more complicated human body shape. Also, I replace certain surfaces of the folding into the 3D woven structure I created. Do you still remember the woven structure? And I'll imagine it would take much effort if you want to produce by hand, but through computer software, there are no more than 5 steps of button clicking to merge them together. Okay? But on the other hand, hand making is still valuable. Like I mentioned in the previous project, I really needed to print out the sample to feel the material in order to continue my design. So apart from this tactility or materiality, hand making also helped me to solve sophisticated problems that I encountered with digital making. So about that time, 2017, my collaborator, Sinterred, their 3D printer machine size were, the dimensions of the machine size were 11 by 15 centimeter, fairly too small for even just a part of the garment. So I decided to cut the design into pieces digitally, 3D print them out, hand stitched, mixed it with conventional hand pleating. So therefore, in my research, there's always this bouncing between digital and hand making. It's almost for me as being a digital programmer and a craftsman, right, to use the conventional technique. And through more themed performance, and these projects really challenge people's existing knowledge of their familiarity with fashion, textile, materials, 3D printing, and even conventional Beijing opera. We remove the overwhelming, very often the overwhelming Chinese opera, so by using more contemporary black and white colors, and also cutting edge 3D printing technology, interesting geometry. So that's the new idea of parametric thinking 2.0, emphasizing the understanding of the human body from fashion textile perspective when you borrow technology, a technique from other fields. Okay? And that's my research and the practice really led to my current teaching positions and teaching experience, as well as other ongoing research projects and enterprise activities. I have been teaching in higher educations, including 3D printing, parametric design, wearable technology, at the Royal College of Arts, Ancient University, at Ancient Textile Engineering University in France. And I teach close 3D sustainable digital fashion design, fashion communication and promotion at Kingston University, University of Portsmouth, Tsinghua University. I currently teach at Kingston, and previously I taught at University of Portsmouth and Tsinghua University. And previously I delivered Ponca knitting software, simulation software at University of Leeds. And I teach digital language, semiology, visual communication at Istituto Marangoni, including all sorts of digital software, animation tools, design tools, game engines. And all of these has fitting to my current main contribution in academic fields. I'm leading a brand new, entirely new program called MA Digital Fashion at the University for the Creative Arts. So this program is about digitalization, fashion, metaverse, and gamification. But it's not only for digital virtual-only garment. It is about the concept I've just mentioned, about the transformations of digital and the physical sphere. We're not losing any of the beautiful designs and hand makings. Okay, we're combining them together. If any fashion textile companies or 3D printing companies are interested in doing a live project with us, feel free to do that. And last year, we collaborated with Farfetch. Do you know Farfetch? Fashion luxury retail company, and to rebrand their future fashion metaverse. And we also at Kingston collaborated with Savile Row tailoring company Scapple, men's suit companies to rebrand, to rebuild the digital experience for the e-commerce. Okay. And then those are some of my research activity enterprise. So if any of you are interested, feel free to talk to me about that. For instance, I'm collaborating with Eindhoven University Technology and Spectral Plus Bio 3D printing company, and this is their Bio 3D printing sample on a project called Fashion in Metaverse towards 3D printed silicon, soft robotic parametric skin. So you can see, you can trace my sort of research being stepped into, being adapted into or molded into something else using latest material. And then I'm writing this review paper of 3D bioprinting for fashion textile, because previously we have bioprinting for fashion textile, 3D printing for fashion textiles, and now it's more about more niche area, interesting fields for fashion textile in collaboration with Central St. Martin and Royal College Art Bio Design Pathway. And then I'm collaborating with London, University College London, Central St. Martin, Royal College Art, Hong Kong Polytechnic University on a project called Biosolar Cell Technology for Energy Restoring Harvesting in Fashion Textile Applications. So more about how cutting-edge technology, wearable technology, sensory technology, 3D printing can be used for sustainable fashion textile practices. And then during the pandemic, I launched this, my startup company called Tell Me Wearable Technology. So that's everything I wanted to mention. If you're interested in talking about these collaborations, collaboration of projects or live projects with my students, feel free to contact me. And to end my presentation today, I'd like to borrow Laura Richardson's statement in terms of the relationship between science and creative art. She mentioned, science is as one lens, creative art another. We see more deeply by using the two lenses. That's it. 29 minutes.